Hey there, and welcome to Earth Up. This is a little corner of the internet where curiosity can stretch its legs, where big questions are allowed to arrive slowly and sit with us for a while. Tonight's idea is a strange one, and the kind that might quietly linger in the back of your mind long after this video ends. We're not talking about breaking news or the latest flashy discovery. This is more like the kind of thought that drifts in late at night, when the house is quiet, when your brain is just restless enough to wander a bit further than usual. The question is this: what if the very first civilization on Earth wasn't ours? At first, that sounds like the opening line of a sci-fi novel. You might picture aliens, lost continents sinking beneath the waves, or some secret ancient empire hidden under the ice. But the idea I want to explore tonight is actually much closer to home than that. To get there, we have to zoom out. Think about the full history of our planet. Billions of years of it. If you stretched Earth's timeline out in front of you, our entire human story, every king, every empire, every invention, every name you remember from history class, would fit into just the tiniest sliver at the very end. The rest of that line, that's oceans rising and falling, continents drifting, colliding, and tearing apart, volcanoes erupting, ice sheets advancing and retreating, forests growing where deserts used to be, deserts forming where oceans once stood. Animals we will only ever know from fossils. Whole ecosystems that lived and died without a single human ever seeing them. And maybe, just maybe, something else. Something that thought and planned and built long before we ever picked up a tool. Before we go any further, I'd actually love to know where you are right now. Are you wrapped in the calm of nighttime, with the room lit only by a small lamp or phone screen? Is sunlight spilling across your floor, with this play in the background while you're doing something else? Are you on a bus, a train, a plane, watching the world slide past a window? Or tucked into that one chair or spot on the couch that always feels like yours? Wherever you are, and whenever it is for you, we're meeting in this shared moment to lean into an idea together. Imagine a world that we can't see anymore, one that might have held more than we realize. If this kind of quiet, wandering curiosity is the sort of company you like, unhurried, calm, a little philosophical, it would mean a lot if you left a like, subscribe, or shared this with someone else who might need a gentle thought to fall asleep to. It's a small thing, but it helps these slow, quiet conversations find new ears. Almost like keeping a light in the window for fellow travelers. So, let's begin somewhere simple. Not with us, but with Earth itself. Not the Earth with cities, roads, airports, and screens. The Earth before anyone walked upright across it, before languages, before calendars, before anyone looked up at the sky and wondered why. Back then, there were no highways slicing across the landscape, no farmland in neat squares, no distant hum of engines. There were just skies and oceans, coasts that looked nothing like the ones we know now, continents in the wrong places, drifting slowly across the planet's surface like massive rocky rafts floating on molten rock. If you looked at a map from some of those ancient ages, you wouldn't recognize it. Land masses would be merged or torn apart in shapes we've never seen. Mountains that don't exist anymore would have been young and sharp. Others that we know now might not have risen yet at all. It's easy to imagine that pre-human Earth is empty, as if nothing important was happening until we arrived. But it wasn't empty. It was full. Every niche was taken. Creatures swam, flew, crawled, and crept into every available space. Some of them would feel vaguely familiar. Early relatives of things we know. Others would look like something out of a dream or a nightmare. There were minds in those bodies, too. Not human minds, but minds all the same. We tend to treat human intelligence as a kind of crown jewel, the one thing that separates us from every other species. But if you look around the life we share the planet with now, intelligence is scattered everywhere in surprising ways. Crows and parrots can solve puzzles and use tools. Dolphins recognize themselves in mirrors. Octopuses unscrew jars, escape tanks, and use objects to protect themselves. That's just what we see in our time, in the world shaped by us. So here's the twist. What if there was a time when intelligence didn't just flicker in scattered individuals, but built itself up into something larger? What if, long before us, there was a species that didn't just survive, but built a civilization, something that learned to shape its environment, to make tools, to organize itself, to leave a mark, and then vanish so completely that we don't recognize it as a sum at all? This is where we run into a problem. Earth is a very forgetful host. Our planet is constantly editing itself. It keeps some stories for an incredibly long time and erases others almost right away. Think about a modern city. If we walked away from it tomorrow and no one maintained it, nature would start taking it back shockingly fast. Within a few decades, plants would break through the concrete, windows would shatter, roofs would collapse. In a few hundred years, many structures would be unsafe ruins. In a few thousand, the most obvious traces might be buried or unrecognizable. Now stretch that out. 1,000,000 years, 10 million, 50 million. By then, continents may have shifted. The ground itself might have risen, folded, or sunk. Rivers could have rerouted. Coastlines would be completely different. Buildings, metal, plastic, concrete. Everything will be cracked, pulverized, and mixed into new layers of rock and soil. Not because anyone tried to wipe the slate clean, just because that's what a living planet does. It turns its own pages over and over, writing new layers on top of old ones. So here's the uncomfortable question. If there had been a civilization millions of years before us, would we even know? We like to think the answer is
Rivers
yes,
could have
of
rerouted.
course. We
Buildings,
picture archaeologists
metal,
digging down to find
plastic,
lost cities,
concrete,
stone monuments,
everything would be
statues,
cracked,
tools.
pulverized,
That
and
works
mixed
well for our
into
own
new
history,
layers of
because
rock
we're
and
only looking
soil.
back tens of thousands of years at most. The oldest human-made stone structures we know of are around 12,000 years old. That sounds ancient, but compared to the age of the Earth, it's barely a breath. If we try to look for something that lived, say, 50 million years ago, we'd be dealing with rock layers that were forming while that hypothetical civilization was alive. Those layers have since been pushed, tilted, buried, heated, shattered, and sometimes melted. They've moved miles from where they started. The older the rock, the less clearly it remembers. This is part of why some scientists have played with a thought experiment called the Silurian hypothesis. The name comes from science fiction, but the question is serious. If there had been an industrial civilization on Earth millions of years before humans, could we detect it now in the geological record, even if every artifact, every building, every tool is gone? Instead of looking for statues or temples, the idea is to look for traces in chemistry, unusual metals in certain layers, strange shifts in the atmosphere locked into ancient ice or rock, thin bands of radioactive isotopes, subtle fingerprints of industry, like the ones we are leaving behind right now. We already know that our own activity has carved a signature into the planet. There are ice cores and sediments that record rising carbon dioxide. There's a distinct layer from nuclear testing. There are plastics and synthetic chemicals spreading through soil and ocean floors. Long after our buildings are gone, those hints might still be there. Now flip that around. If that kind of signature is the most likely thing to survive our time, could something similar from a much older civilization already be buried in the rocks we've studied? Maybe we've already walked past it. A streak of strange metal in a cliff. An odd mineral deposit that was filed away as unusual but natural. A pattern in ancient sediments that didn't quite fit, but didn't seem important enough to rewrite the textbooks over. Not because scientists aren't paying attention. They are, but because pre-human industrial civilization just isn't the first explanation you reach for when you look at a rock. Thinking about all this doesn't mean we have to believe in secret histories or hidden conspiracies. It's not about rewriting everything we know. It's more like an exercise in humility. We like to see ourselves as the first, the only, the pinnacle of life on Earth. But we're part of a much longer Messier story. One that's been interrupted by mass extinctions, climate swings, and continental collisions. A story where entire ecosystems come and go faster than we can easily imagine. We know intelligence isn't a neat ladder with humans at the top. It's more like a tangled bush, with branches going off in all directions. Ours is just one branch that happened to grow in a particular way. So if there was a civilization before us, if some other minds once built, created, and dreamed on the same planet, what might they have been like? That's the path we'll start to walk next. If there really was a civilization before us, what kind of world would have lived in? Not just what the beings were like, but what the air felt like on their skin, what the sky looked like, what sounds filled their days. For now, it's enough just to hold the idea in your mind that the deep past wasn't an empty stage waiting for us to arrive, but a rich, strange world in its own right. Before there were people writing dates in calendars or arguing about history online, the Earth was already very old. By the time the first humans appeared, the planet had already watched billions of sunrises and sunsets. Entire mountain ranges had been raised from the seafloor and then worn back down to stumps. Others were just beginning to rise. The continents you see on maps today are not permanent fixtures. They wandered slowly over the surface, colliding, breaking apart, edging close to the poles, or drifting toward the equator. If you could look down at Earth from space tens of millions of years ago, you'd still see blue oceans, white clouds, and patches of green. But the outlines of the land would feel wrong to you. Familiar colors, unfamiliar shapes. Some eras were warm and humid almost everywhere, with lush forests stretching close to the poles. Imagine palm-like trees and dense jungles where today you might find snow and ice. Other times, ice pushed much farther toward the equator, and the whole planet shivered. Seas rose and fell over and over again, drowning coastal plains, then pulling back to reveal new beaches and muddy flats. Whole ecosystems came and went in these cycles, like sets on a stage being swapped out between acts. From our perspective, trying to reconstruct all this from rocks and fossils, the Earth hasn't been one world. It's been many worlds, stacked on top of each other in time. And in those worlds, life was everywhere. The ocean floors were busy with creatures that never saw sunlight, living around volcanic vents and in the dark depths. Coral reefs grew, died, and grew again in new places. Swamps buzzed and croaked and rustled with animals that would look completely alien to us without the help of museum reconstruction. On land, forests rose and fell too. Trees with no living relatives today dominated some landscapes. Under their branches moved a shifting cast of animals, some small and skittish, some huge and heavily armored, some fast and predatory. Insects had already been around for ages, well established long before dinosaurs appeared. Birds evolved from small feathered dinosaurs and took to the skies, learning to ride air currents and migrate across vast distances. Mammals were there as well, often small, often nocturnal, living in the shadows and margins while larger reptiles ruled the open spaces. If you could stand for a moment in one of those ancient landscapes, it might trick you at first. Wind would still move through leaves. Water would still flow downhill and pool in low places. The sun would still rise, arc across the sky, and set again. Clouds would still roll in. Rain would still fall. It would feel like Earth. But the details would betray the difference. The air might hold a different mix of smells, from plants that no longer exist. The sound would be wrong, calls, songs, chirps, and growls your ears have never heard. The colors of the foliage might be subtly off, shaped by climates that no longer exist. The animals would be a blend of almost familiar, and what on earth is that? Some of them lived in flocks, herds, or colonies. They communicated in ways we can only guess now. Sound, color, posture, scent. They hunted together, migrated together, raised young together. Many of them had brains sophisticated enough to learn, to problem solve, to remember. Not necessarily civilized in the way we mean it, but not simple either. And somewhere in that long, busy history, it's not impossible that one branch of life took a different path. One that led not just to cleverness, but to something more like what we call a civilization. A species that didn't just survive in its environment, but deliberately reshaped it, not just for food or shelter, but for comfort, for security, maybe even for curiosity and art. We know such a leap is possible because it happened with us. Our own journey, from small bands of hunter-gatherers to builders of cities and satellites, took hundreds of thousands of years. Intelligence didn't appear overnight. It was molded by shifting climates, changing landscapes, competition, cooperation, and a lot of trial and error. So if evolution gave us that path once, it's not unreasonable to wonder whether it might have given some other species a similar opportunity, just at a different time, under different skies, surrounded by different creatures. The problem is, the record of those times is full of holes. Fossils, as dramatic as they look in museums, are incredibly rare. Most living things vanish completely when they die. They're eaten, broken apart, scattered, and decomposed. Only under very specific conditions, rapid burial, low oxygen, stable chemistry, does a bone, shell, or leaf get slowly replaced by minerals and turned into stone. And even when bones do fossilize, they're limited storytellers. A skeleton can hint at brain size, posture, and maybe some aspects of behavior. It might suggest whether the animal lived in groups or hunted in a particular way. But it can't tell you what that mind was thinking. It can't show you whether there were stories, traditions, or shared knowledge. Stone tools and structures survive better than flesh and bone, but even they depend on luck. They have to end up in places that protect them from erosion, landslides, and the grinding motions of tectonic plates. Over millions of years, huge chunks of the Earth's surface are lifted, worn away, buried, or dragged down into the mantle and melted. The crust isn't a permanent stage. It's a set of moving platforms constantly rearranging themselves. Oceans open and close. Mountain ranges rise, then crumble. Old seabeds get shoved up to form new continents. Frozen ground melts. Solid rock twists and buckles. Any physical trace of civilization would have to survive all of that, and the odds are not in its favor. And even if something did survive, we'd still have to recognize it for what it is. Imagine a worked piece of stone, something carefully shaped tens of millions of years ago, being found today all by itself, out of context. It might be cataloged as an interesting natural shape. A subtle chemical oddity in a rock layer might be written off as a quirk of ancient volcanoes or ocean chemistry. Unless you're actively looking for signs of an ancient civilization, it's easy to miss the possibility that something might not be natural at all. That becomes even clearer when you think about how much can disappear in a relatively short time. Picture an entire continent, covered in forests, dotted with towns and cities built by a species that never met us. Maybe they dug mines, carved roads, built shelters, or monuments. Maybe they farmed or cultivated something like coral or shaped living plants into structures. Now fast forward the clock. Sea levels rise. Ice advances and retreats. River systems shift, cutting new paths and abandoning old ones. Volcanoes erupt. Earthquakes reshape coastlines. Over a few million years, almost everything they made could be broken up, buried, or utterly transformed. A few stubborn traces might remain, deep underground, in an old riverbed turned to stone, or in sediments at the bottom of a long-vanished lake. But the rest would be gone, not just hidden, but recycled into the planet itself, as if it had never happened. We do know of cases where the Earth has held on to a memory much longer than usual. Petrified forests, where tree trunks have been turned to stone, but still stand upright. Insects frozen in amber, perfectly detailed after tens of millions of years. Footprints preserved in ancient mud that turned to rock before anything could disturb them. But those are rare accidents. Tiny slices of time saved by extremely specific conditions. For a whole civilization to be recorded that way, the universe would have to be unbelievably generous with its coincidences. Without that kind of luck, their existence would disappear into the same silence that has swallowed most of the species that ever lived. Thinking about this doesn't require us to believe it happened. It just opens the door to the possibility. And once that door is open, it's hard not to ask more questions. If there was such a civilization, were they few or many, spread across the world, or concentrated in one region? Did they build with stone, or with something that rots in a few years? Did they live in permanent settlements or move with the seasons, leaving only light marks on the land? Would their art, if they had any, be something we'd even recognize as art? Or would it be expressed in materials, colors, and patterns that meant everything to them and nothing to us?
Imagine
We don't have
finding a
answers,
single,
but we do have
carefully shaped
imagination.
stone
And
from
imagination
tens of
is
millions
often the
of
first
years
step toward
ago.
knowing what to look for.
Would we see it
Scientists
as a
don't just follow
tool,
the evidence.
or
They
just
also
an
follow ideas
interesting
about
rock?
what evidence might exist. A thought like, what if there was a pre-human civilization? Can shift the kinds of questions we ask about the rocks under our feet and the fossils we find in them. Because Earth hasn't just been one version of itself. It's been many, world after world after world, layered in time. Jungles where there's now desert, ice where there's now open ocean, creatures with shapes and abilities that don't exist anymore. In all that change, it's not impossible to imagine that intelligence rose more than once, lived its span, and then disappeared. And if it did, then the only witness left is the planet itself. Long before we ever showed up, the Earth wasn't quiet. It didn't sit in some peaceful, empty waiting room, twiddling its thumbs until humans arrived. It was already full of sound. Wind rushed through plants that no longer exist. Unknown animals called to each other across swamps, forests, and plains. Rivers carved their way through rock that's since been lifted, folded, and ground down. The planet was loud with life, just not our kind of life. And somewhere in that noise, there might have been minds that worked a little like ours do, minds that noticed patterns, minds that remembered things not just for survival, but for their own sake, minds that imagined outcomes before they happened, minds that dreamed. We're tempted to treat dreaming as something uniquely human, tied to our storytelling and our ability to imagine what isn't there. But animals dream. We can see in the way their brains behave during sleep, in the way a dog twitches its paws like it's running, or a cat's whiskers flicker as if it's stalking something. Birds move their eyes beneath closed lids. Their brains go through cycles very similar to ours. Dreaming seems to be something brains just do once they reach a certain level of complexity. They replay experiences. They mix them up. They test possibilities. You don't need human language for that. You don't need books or buildings or cities. You just need a nervous system that can take what it's gone through, shuffle it, and recombine it into something more than a simple recording. If that's true, then there could have been many species before us that dreamed. Most of them probably dreamed in ways shaped by their needs: hunting, avoiding predators, finding shelter, caring for their young. But a few might have gone further. They might have dreamed in the way we do, inventively, not just replaying old events, but making new ones, seeing tools they hadn't used yet, imagining strategies they hadn't tried, testing futures that hadn't happened. Once a mind can imagine something that isn't real, yet you have the seed of invention. The step from "I found a stick, it's useful" to "I'm going to shape this stick for a purpose" is small in evolutionary terms, but enormous in impact. That's the moment you stop being purely at the mercy of your environment and start editing it. You can build shelters instead of just finding them. You can store food for later instead of only eating what's in front of you. You can prepare for dangers that haven't arrived yet. And crucially, if you can share that kind of insight with others, it doesn't stay locked inside one brain. It can persist. It can improve. It can become tradition. We can already see the early stages of this in species living today. Chimpanzees teach each other how to strip leaves from branches to make tools for gathering termites. Some birds learn to bend bits of wire or twigs into hooks to reach food, and that knowledge spreads through their group. Dolphins in certain areas develop unique hunting techniques and pass them down to their young. These are more than random tricks. They're learned behaviors that spread socially. That's culture in its simplest form, not human-level culture, but culture all the same. And that tells us something important. Intelligence isn't an on-off switch. It's a spectrum. We're not standing on a lonely island of thought. We're on the high end of a long slope that many other species are part of. If we take that seriously and look backward into deep time, it's not hard to imagine that some lineage might push further along that slope than anything alive today. Not just clever tool use, not just social complexity, but something that crossed the threshold into what we call civilization. The difference between clever animal and civilization-building species is mostly about degree and time. You need enough intelligence, enough social structure, enough communication, and enough stability for ideas to stack on top of each other rather than constantly being lost and reinvented. Given millions of years, even a modest start could go a long way. So what would it have taken for that leap to happen before us? Big brains help, but they're not the only ingredient. Social structure matters. You need to care about what others think and do. Intelligence tends to grow where animals have to navigate complicated relationships, alliances, hierarchies, and cooperation. Communication matters. If you can share ideas quickly and accurately, discoveries aren't reset every generation. Knowledge doesn't die with each individual. Curiosity matters. That urge to poke at things that aren't immediately useful. to explore beyond the minimum you need to survive. That's where a lot of innovation comes from. In our case, all of those lined up in a specific way. But evolution doesn't run only one experiment. It runs countless ones at once. Maybe, long before we arrived, those conditions lined up somewhere else along a different branch of the family tree. We often picture intelligence as looking like us. Upright posture, hands with fine control, eyes facing forward, a mouth capable of a wide range of sounds. But that's just our body's particular toolkit. Another intelligent species could look completely different. They might have lived in water, using fins, tentacles, or flexible limbs to manipulate their surroundings. They might have flown, using claws and beaks to build and gather, seeing the world from above as they mapped huge territories. They might have been small, relying on cooperation and numbers instead of size and strength. Intelligence finds a way to express itself using whatever body plan it's given. If such a species existed, their dreams might have been as varied as ours. Maybe they imagined better hunting strategies, safer ways to raise their young, or new ways to explore dangerous environments. Maybe they told each other stories, even if their stories didn't sound anything like our languages. They might have decorated their shelters, changed their appearance, or created patterns just because they enjoyed them. That's one of the strangest marks of a complex mind, doing things not strictly necessary for survival. Art, however it appears, is a kind of signal. It suggests a mind that values beauty, symbolism, or at least the satisfaction of creation. That's the kind of mind that might build something we'd want to notice. But most dreams don't leave marks. Even for us, the vast majority of what we think and imagine never turns into anything physical. It dissolves the moment we wake up or the moment we get distracted. Civilizations only leave behind a tiny fraction of what they create, and that fraction is fragile. Stone survives longer than wood. Fired clay survives longer than cloth. Metal can last a long time, but given enough water, salt, and time, it also corrodes away to nothing. Without very special conditions, most of what any civilization builds will eventually disappear. The older the evidence, the more likely it is to be ground down, buried, or altered until nothing recognizable remains. That's why, when scientists think seriously about whether an earlier civilization could have existed, they tend to focus less on obvious artifacts and more on indirect signs. Not ruined buildings or fossilized machines, but things like odd changes in the chemistry of rocks, sudden shifts in climate that don't line up neatly with known natural causes, unusual deposits of metals or compounds that don't normally appear in large quantities. These are the geological equivalent of faint footprints on a very old path. The problem is that nature itself is extremely good at making weird patterns. Volcanoes, meteor impacts, and ocean changes can all create sharp, surprising signals. Distinguishing civilization from planet doing planet things is incredibly difficult, especially when you're looking tens of millions of years into the past. Still, the thought doesn't go away. Somewhere, at some time in Earth's long history, it's not beyond possibility that the first minds capable of dreaming like we do took the first steps toward building something more. Maybe they started small, little groups scattered through a dangerous world. Maybe they sheltered in caves or built nests and platforms that lasted beyond a single season. Maybe they experimented with fire or with some other controlled source of energy. Each step would have widened the gap between them and the other creatures around them. If they got far enough, they might have spread into new environments, adjusting their tools and habits to fit each place. Some groups might have traded materials or food. Some might have become specialized in certain skills. Over long stretches of time, those small changes could build into something like our earliest cities. Hubs where goods, ideas, and techniques piled up and cross-pollinated. The details are invisible to us now, but the shape of that path is familiar. It's the path we walked. And evolution doesn't have a rule saying it can only be walked once. Whether any of their work survived long enough for us to find it is a different question. The fossil record, even for species we know existed, is full of holes. Most of the story is missing. We're working with scattered bones, fragments of shell, bits of leaf, and thin slices of sediment. The idea of a pre-human civilization is so hard to prove or disprove because the planet is always rewriting itself. The absence of evidence is a clean no. It's more like the earth shrugging and saying, if it was here, I may already have recycled most of it. Time just keeps moving. It doesn't pause to make an archive for anyone. And so we're left with a strange, quiet possibility that the first minds that dreamed and built on this planet might have risen, flourished, and vanished so long ago that their story is now buried almost completely. All we can do is imagine them walking across landscapes that no longer exist, leaving traces that may or may not still be there, and wonder what it would mean if we're not the first to call this world home. Up to now, we've been using the word civilization as if we all quietly agree on what it means. But do we really? When we say civilization, most of us instantly picture tall stone buildings, paved roads, complex writing systems, maybe huge monuments carved with intricate symbols. We think of empires, laws, governments, libraries, and cities glowing at night. But that's just one very specific version of civilization. Ours. If we strip the word back to its core, it isn't actually about skyscrapers or marble statues. At its heart, civilization is about a way of living where knowledge, culture, and technology accumulate over generations, where each generation doesn't just start over from zero, but builds on what came before. By that definition, civilization is less about what a place looks like and more about how society organizes itself and passes things on. A group could live in structures made entirely from natural materials, wood, woven fibers, earth, even living plants, and still be a civilization if they figured out how to coordinate large groups, manage resources, store knowledge, and shape the environment to their needs. Stone monuments show up a lot in human history because stone happens to last. But the stones aren't what makes something a civilization. They just happen to be what sticks around. We also tend to think big. When someone says civilization, we imagine sprawling empires with millions of people, networks of roads, and grand capitals. But human civilization didn't start that way. It started with small, scattered communities connected by trade, shared rituals, stories, and techniques. There was no single headquarters, no worldwide map, just groups who gradually came to share ideas, tools, and customs across wide areas. What made them part of the same civilizational story wasn't a single ruler or a central city. It was the fact that knowledge flowed between them, and that flow changed how they lived over time. So if we're going to ask whether there might have been a civilization on Earth before humans, we have to be careful not to limit ourselves to things that look like Rome or ancient Egypt or modern megacities. A non-human civilization might never have built anything that resembled a human city. It might not have farmed in neat rectangles. It might not have used metal at all. It could have taken advantage of completely different resources and environments shaped by its own biology and senses. Even something like the idea of a city might be different. Maybe not a dense cluster of permanent buildings, but a network of seasonal gathering spots, places where groups come together at certain times of year and then disperse again. From above, that might not look like much. But socially, it could
Civilizations
be every
only
bit as
leave
rich and
behind a
organized
tiny
as a brick
fraction
and
of
concrete
what
metropolis.
they create.
One of the big
And
traps in
that
thinking about
fraction is
civilization
fragile.
is that we tend to use
Stone
ourselves as
survives
the
longer
measuring
than
stick.
wood.
We treat writing,
Fired
for
clay
instance, as
survives
a major
longer than
milestone.
cloth.
And for us, it is. But writing is just one way to store and transmit information. Oral traditions can be incredibly complex and accurate. Some human cultures have passed down stories, navigation routes, and detailed ecological knowledge through spoken word for thousands of years without a single written symbol. We also love monumental architecture. We treat huge stone constructions as obvious signs of sophistication. And sure, they're impressive. But a civilization might channel its brilliance into things that don't last as long. Wooden architecture, textiles, performances, living sculptures made from plants, or arrangements of materials that decay quickly. Large dams and walls impress us. But small, precise changes in an ecosystem can be just as advanced, reshaping rivers subtly, cultivating certain plants or animals, tweaking the environment without leaving giant scars. If a non-human civilization existed millions of years ago, its way of life might not neatly match our categories at all. They might not have used domesticated crops in rows. They might not have herded animals like we do. They might have worked with fungi or coral-like organisms, or with social insects, or with living trees, in ways we never think to look for. They might have changed the world in forms we'd misread as natural gradient rather than deliberate design. That's why our definition of civilization matters so much. If we only look for carbon copies of ourselves, stone temples, metal tools, writing carved into rock, we risk missing signs of something very different, but just as complex. At the same time, we can't call every organized animal society a civilization. Ants and bees, for example, build highly structured colonies. They have division of labor, large-scale construction, and even agriculture of a sort. But most of their behavior is hardwired by evolution. It changes slowly, through genes, not quickly through ideas. The key difference between social insects and a civilization like ours is cultural innovation that builds on itself, learning and adapting in ways that aren't just genetic, but shared intentionally and improved over time. Archaeologists looking at early human societies look for certain clues: signs of long-distance trade, evidence of specialized roles, symbolic objects like art or ritual items, and settlements that support groups larger than just extended families. None of that requires stone buildings or metal. It just requires organization, cooperation, and some form of shared culture. Those same markers could, in theory, show up in the fossil record of a non-human species, even if their tools and structures were made of materials that didn't survive. The problem is, without direct artifacts, we're trying to read the outline of a story that's mostly been erased. There's also the question of scale and duration. How long does something have to last before we call it a civilization? Some human civilizations have lasted thousands of years. Others burn bright and collapse in just a few hundred. In geological time, even 1,000 years is barely a flicker. But in that flicker, a lot can happen. Forests cut down, rivers redirected, species move from one region to another. Those changes sometimes show up in the geological record as shifts in pollen, soil composition, or animal bones. If a pre-human civilization lasted long enough and changed ecosystems at a large enough scale, we might expect similar signatures. But here's the problem. Nature can produce similar patterns all by itself. A perfectly round hill might be a volcanic cone, not a man-made mound. Straight lines and rock layers might come from the way stone fractures, not old roads or walls. A sudden change in plant species might reflect a cooling climate, not deliberate planting. To confidently say, this was a civilization, we want multiple lines of evidence all pointing in the same direction. Unusual materials, altered landscapes, maybe hints in the fossil record of a species with both the physical traits and the social behaviors to support high-level culture. And even then there'll be debate. What would those beings have looked like? We often assume you need something like hands to make technology, dexterous fingers, joints that allow fine manipulation. That's because we use hands for everything. But that may just be one solution among many. A civilization could, in theory, evolve from creatures with tentacles, or strong prehensile feet, or beaks and claws clever enough to shape and arrange materials. They might have used their entire bodies as tools, or worked together in ways that distributed tasks across many individuals. They might have been aerial, building along cliffs and in treetops. They might have been semi-aquatic, living along coasts and estuaries, dividing their time between water and land. Their architecture might have been grown rather than built, coaxing living organisms into shapes that serve their needs. All of that would be incredibly hard to reconstruct millions of years later if the structures themselves vanished. This is part of what makes the idea of a pre-human civilization so compelling and so slippery at the same time. It pushes us to zoom out from our own example and ask, what really defines a civilization once we strip away the human-specific details? Is it cities? Or is it accumulated knowledge? Is it stone monuments? Or is it the ability to shape the environment in increasingly deliberate ways? Is it writing? Or is it any system that preserves information beyond a single lifetime? When we look at Earth today, we see hints of alternate paths all around us. Elephants reshape landscapes by knocking down trees and digging for water. Beavers create wetlands by building dams that outlast generations. Some birds build intricate structures to impress mates, sometimes reusing and expanding them. Whales sing songs that spread and change over time, almost like musical traditions. None of these quite cross the line into what we call civilization, but they show how close nature can get using totally different bodies and lifestyles. In another world, with different pressures and more time, those edges might have been crossed. Once we accept that civilization might not always look like ours, the obvious next question is, if something like that had happened long before we arrived, how would we even begin to look for it? When people imagine searching for a long-lost civilization, the image that usually comes to mind is pretty dramatic. You might picture someone brushing dust off a carved statue, or prying open an ancient sealed door, or pulling a strange metal object out of the ground, and realizing it changes everything. Real science is usually much quieter than that. Most of the time, it doesn't begin with a perfectly preserved anything. It begins with fragments, a chipped bone, a thin layer of ash, a smear of unusual chemistry in a rock core. If you picture paleontologists as treasure hunters, it's easy to be disappointed. In reality, they're more like translators of language that's been written slowly into the earth, then smudged, folded, and torn. A fossil isn't a corpse frozen in time. It's a replacement. The original bone or shell or leaf doesn't survive. Over long stretches of time, mineral-rich water seeps through the buried remains, and atoms slowly swap places. Bit by bit, the original material is replaced with rock. Sometimes, even the thing itself is gone and only an impression remains, like a footprint in mud that hardened before anything could distort it. And usually, none of that happens at all. The conditions needed to make a fossil are rare. You need something to die in just the right place. It has to be buried quickly. It has to be protected from scavengers and oxygen. The water chemistry has to cooperate. Then, that chunk of earth has to avoid getting smashed, melted, or eroded away for millions of years. Add all that up, and you start to see why the fossil record is so patchy. Whole species, entire ecosystems, can exist for millions of years and leave behind almost nothing we can find. It's not that they weren't there. It's that the planet didn't save a copy. Even where fossils do form, the record is biased. We have more fossils from environments that are good at quickly burying things. River deltas, lake beds, floodplains, ocean floors. We have fewer from mountains, uplands, or coastlines that are constantly changing. So when someone says, we don't see any fossils of a pre-human civilization, so it probably didn't exist, that's not quite as solid an argument as it sounds. Our view of the past is stitched together from a handful of surviving pages in a book where most of the chapters are missing. Now imagine trying to see signs of civilization in that. Even in our own relatively short history, our footprint is uneven. Some ancient cities built in deserts or dry climates have left behind striking ruins. But coastal settlements that were flooded or forest villages made mostly of wood and thatch have disappeared almost entirely. Now scale that up over tens of millions of years. If an advanced society once lived near what was on a coastline, that whole region might now be underwater, or long since abducted into the Earth's mantle. If they lived in forests later scraped clean by glaciers, their world could have been erased down to raw bedrock. Geologists and paleontologists know this. They work with an understanding that every discovery is just one dot in a vast, mostly invisible pattern. And they also know that not every important clue is obvious. A single tooth can hint at diet, lifespan, and where an animal sits in the evolutionary tree. A thin layer of pollen trapped in sediment can reveal entire ancient forests and climate shifts. Tiny chemical differences in rock can point to volcanic eruptions, asteroid impacts, or sudden changes in atmosphere. Those sudden changes, the weird, sharp shifts, are the kind of thing that might hint at something unusual going on. In our case, we already know we're leaving behind sharp signals. Our use of fossil fuels is changing the balance of carbon isotopes in the atmosphere and oceans. Our industries are scattering metals and synthetic compounds into sediments worldwide. Our nuclear tests have sprinkled radioactive isotopes into the environment. If you pulled a core sample millions of years from now, you probably see a narrow layer where the chemistry looks off, different from what came before and what comes after. If a civilization existed long before us, and it had anything like an industrial phase, you might expect something similar, a brief, sharp chemical accent in the rock record. But here's the catch. Nature does weird, sudden things too. Massive volcanic eruptions can dump huge amounts of sulfur, carbon, and other elements into the atmosphere. Meteor impacts can scatter rare metals and shock minerals into a thin global layer. Large die-offs can leave bands rich in carbon from all the life that suddenly ended. Sometimes, when scientists study certain rock layers, they do find odd shifts in chemistry or mineral content that don't have a clear, clean explanation. Most of them eventually get pinned on natural processes, massive lava flows, changing ocean currents, weird climate events. But every time they find one of those anomalies, the what if hangs in the air for at least a moment. What if, long before we were here, something else altered the environment in a way we don't fully understand yet? If we ever did stumble across such a clue, it probably wouldn't look like a smoking gun. It wouldn't be a fossilized skyscraper. More likely, it would be a pattern. Maybe you'd see a layer of sediment with unusual spikes in certain metals, a strange shift in carbon isotopes, a change in fossil pollen that suggests rapid reshaping of plant life, and maybe, just maybe, signs of abrupt warming or cooling that don't line up with known volcanic or impact events. Standing alone, any one of those things could have a natural explanation. Together, they might raise eyebrows. But even then, we'd be cautious. Science isn't quick to jump to hidden civilization as a conclusion. The standard rule is, extraordinary claims require extraordinary evidence. And the deeper into the past we look, the more that evidence is smudged and broken. That's why, instead of thinking like treasure hunters, the people who study deep time have to think like detectives who showed up to a crime scene hundreds of millions of years late, after the room has been remodeled several times and most of the furniture has been recycled into completely different buildings. They have to accept that much of the story is gone, that the fossils we have are just the lucky ones, that the sediments we can reach are just small samples of a vast archive, and that if an ancient civilization did exist, it would be very easy for almost all of its traces to be erased or misinterpreted. Our job, from this side of time, is to read what's left as carefully as we can. Every layer of rock is a page in the Earth's memory, even if it's torn and faded. Every core pulled from the seafloor is a vertical timeline, stacked with hints. Every cliff face, every canyon wall, every band of color is a cross-section of stories, some of which we can read, some of which we can't. Looking for signs of a prehuman civilization, and all of that is like looking for a faint watermark in a book that's been soaked, dried, cut up, and glued into a new one. It's possible there's nothing there. It's also possible that if something is there, we've already walked past it without knowing what we were seeing. And that leads naturally to another question. If the surface of the Earth is so good at wiping itself clean, what about the parts of the planet we almost never see? The Earth remembers, but not the way we do. Our memories are little flashes, moments, conversations, scenes we can replay. Sometimes sharp, sometimes blurry. The planet's memory is slower and heavier. It's written in layers of rock and ice and sediment. It doesn't store days or years. It stores ages. But it's also a very forgetful kind of memory. The Earth is constantly editing itself. Old pages get overwritten. Whole chapters get torn out. Some are ground down and turned into brand new pages with all the original writing erased. If we could peel back the crust of our planet like the pages of a massive stone book, we wouldn't see a clean, continuous story. We'd see gaps, huge ones, long stretches where almost nothing survives. Not because nothing happened, but because the processes that shape the planet are relentless. Tectonic plates collide and push up mountains. Those mountains slowly wear down under wind, rain, and ice. Oceans open between drifting plates, then shrink again as land masses rejoin. Volcanoes cover everything nearby in fresh rock. Glaciers scrape over continents like sandpaper, stripping away whatever was there before. Even the quiet forces do damage. Rivers carry muddy water that buries some things and erodes others. Coasts crumble under the constant assault of waves. Sand dunes march slowly across landscapes, burying or revealing whatever lies beneath. The surface we walk on today is not the same one that existed 1,000,000 years ago, or 10 million, or 100 million. It's been rebuilt over and over, like a city that keeps getting torn down and remade, but where nobody keeps an archive. In some places, the rocks exposed at the surface are very young, maybe only a few thousand or tens of thousands of years old. In others, the rocks are hundreds of millions, even billions of years old. But even those have usually been twisted, heated, and altered so much that they barely resemble what they once were. The older something is, the less likely it is to survive in a form we can understand. If you want traces of a civilization to last tens of millions of years or more, you need a crazy amount of luck. You'd need their remains to end up in a very stable situation. Not buried too deep, not lifted too high, not dragged underground, not scraped away from above. Even then, time changes almost everything. Heat and pressure reshape rock. Organic materials decay unless they're sealed off from air and moisture. Minerals can dissolve, recrystallize, or be carried away. That's why the earliest parts of Earth's history are such a blur. The planet is about 4.5 billion years old, but the oldest rocks we found are only around 4 billion. Huge parts of that first billion years are just gone, recycled into the interior of the planet, and brought back as completely new rock with no trace of what came before. The same principle applies later too, just on smaller scales. It's not only geology that erases things. Climate and biology help out. A rainforest can swallow a city in decades. Roots pry apart concrete. Moist air rots wood, leather, paper. Insects and microbes break down almost anything. Salt water is brutal on metal. Frost cracks stone. Even sturdy materials like brick and concrete crumble under cycles of heat, cold, wet, and dry. On a human timescale, ruins can feel permanent. A few hundred or a few thousand years seems like forever to us. But on geological timescales, that's just a blink. If humans disappeared tomorrow, the most obvious signs of our presence, roads, buildings, bridges, would start fading almost immediately. Within a few centuries, many would be hard to recognize. In 10,000 years, you have to work to spot them. In a million, you need to be very lucky and know exactly where to dig. Give it 10 million years, and most of what we've built will be gone beyond easy recognition. Maybe a faint imprint in the soil here, an unusual layer of rubble there. And after tens of millions more, even those might be melted, crushed, or eroded away. So when we imagine trying to find traces of a civilization that might have existed 50 or 100 million years ago, we're talking about evidence that would have had to survive multiple rounds of this planetary cleanup. Even the ocean floor isn't safe storage. It seems like it might be. Things sink, get buried in mud, and lie there in the dark. But the crust under the deep oceans is constantly being renewed. New crust forms at mid-ocean ridges, spreads out, and then eventually dives back into the mantle at subduction zones. Most of the ocean floor is less than about 200 million years old. Anything older than that, no matter how well preserved at the time, is gone, not buried, not hidden, literally recycled into the interior of the planet. Continents can last longer, but they're far from stable. They rise and fall, split and collide. Coastal plains get flooded and uplifted. Entire regions go from seafloor mountaintop and back again over the span of hundreds of millions of years. This constant turnover is a big part of why there are so many gaps in the fossil record. It's not that life took breaks. It's that preservation did. If you think of the Earth as a library, it isn't a neat row of well-organized shelves. It's a place where books are constantly being shredded, rewritten, burned, and rebound into new volumes. The few pages that survive are the ones that, by sheer luck, ended up somewhere safe. And yet, those scattered pages are all we have. Every fossil, every rock layer, every preserved pollen grain is precious because it made it through the gauntlet. The same would be true for any artifact of a long-vanished civilization. For something they built to reach us, it would need to be made of material that can survive long-term, to be buried or protected quickly, to avoid being scraped away, melted, or crushed, and for us to eventually dig in the right place and recognize it for what it is. Even then, context matters. A single carved stone or shaped object, out of place in a rock layer tens of millions of years old, might be dismissed as a natural oddity unless we had other clues around it. A strange mineral deposit, without any other supporting evidence, might be chalked up to odd chemistry rather than industry. That's why thinking about the Earth's memory changes how we think about this whole question. It's not enough to imagine what a lost civilization might have built. We have to imagine how those things would interact with erosion, tectonics, and time, how they'd break, how they'd sink, how they'd be buried or transformed. We have to ask, what's the minimum that could survive? What's the tiny fraction that might still be out there, hiding in some ancient layer we haven't studied in detail? Because the planet does remember, but in a very selective way. It remembers in chemical traces locked in stone, in tiny fossils embedded in shale, in echoes of climate shifts recorded as subtle changes in sediment. Most of the rest is gone, as if it never happened. And that, more than anything else, is what keeps the question open. If the Earth can erase almost everything we've done in a few million years, then it's perfectly capable of having done the same thing before. If there were others, beings who dreamed, built, and vanished, their presence might now be no more than the faintest shadows in the rock record. Maybe we've already seen those shadows and filed them under unlikely natural anomaly. The question is whether any of those whispers are still waiting to be recognized, and, if so, what kind of life left them behind? So if the planet has been quietly wiping its own history over and over again, the obvious follow-up is, who, if anyone, might have been here before us? When most of us think about the distant past, one era tends to dominate our imagination: the age of dinosaurs. We picture towering predators with teeth like knives, long-necked giants lumbering through swamps, herds of armored plant-eaters swinging heavy tails. It's a vision full of size and spectacle, a world where raw power seems to rule. But the reign of the dinosaurs lasted for more than 160 million years. That's an amount of time that makes our entire species look like a brief experiment. In all those millions of years, evolution had time to try a lot of things. Not just big and dangerous, but also small, quick, and clever. Alongside the famous giants, there were tiny dinosaurs the size of chickens. There were bird-like hunters with sharp claws and keen eyesight. There were early mammals living in the shadows. There were flying reptiles crossing oceans, and marine reptiles dominating the seas. We know that brain size alone doesn't dictate intelligence, but it does give hints. Some of the smaller theropod dinosaurs, especially those closely related to birds, had relatively large brains for their body size. Their skulls suggest good vision, coordination, and potentially complex behavior. They might have hunted in groups. They might have cared for their young. They might have communicated in ways more sophisticated than we usually imagine. When you look at their modern descendants, birds, you can see what that potential can become. Crows and ravens can solve multi-step puzzles and use tools. Parrots can understand categories, remember long sequences of sounds, and even improvise. Some birds recognize themselves in mirrors, a sign of self-awareness we once thought was rare. If today's birds can do all that, it's not unreasonable to wonder what their ancestors might have been capable of, given different circumstances and enough time. But there's a big leap between clever dinosaur and dinosaur civilization. To cross that gap, you need more than just a good brain. You'd need a body that can manipulate the environment in lasting ways, and a social structure that encourages cooperation and shared learning. That's where the question of anatomy comes in. Dinosaurs, as far as we know, didn't have hands like ours. Some had grasping claws. Others had beaks capable of fine work. Their descendants, birds, do surprisingly delicate things with beaks and feet. But the kind of tool building we're used to seeing in humans might have been harder for them. Harder doesn't mean impossible. A dinosaur lineage with sharp claws, flexible necks, and social behavior might have developed a style of technology very different from ours. They might have relied more on shaping and rearranging natural features, rocks, branches, nests, burrows, than on forging metals or carving blocks. If you try to imagine what a dinosaur civilization might have looked like, it's easy to get stuck in human tropes: dinosaur cities, dinosaur roads, dinosaur statues. But that's probably the wrong way to picture it. Instead, think about structures built along cliffs or in forest canopies, nesting grounds that were carefully maintained and expanded over many generations, arrangement of stones or bones that had ritual or social meaning, communal shelters made from plant material and mud, rebuilt and adapted each season. To us, tens of millions of years later, those might leave almost nothing behind. Wood and fibers rot, mud crumbles, bones and stones it scattered. Even if they shaped landscapes, terraced hillsides, cleared forest patches, redirected streams, those changes could be erased by erosion, glaciation, or later tectonic shifts. And remember, between the last non-avian dinosaurs and us, there's been a lot of geological activity. Continents have moved. Mountains have risen and worn down. Sea levels have gone up and down again and again. If you wanted to hide a civilization, letting 65 million years of Earth's normal processes do the job will be more than enough. Still, the idea that intelligence might have bloomed among dinosaurs isn't completely wild. For most of their time on Earth, they were the dominant land animals, filling almost every ecological role. If complex cognition were going to evolve on land during that era, it would make sense for it to emerge in one of the groups already thriving. And in a way, maybe it did, just not in a way that turned into cities and metal. Modern birds are technically dinosaurs. Their intelligence, their social behavior, and their problem-solving abilities could be echoes of possibilities that never fully played out in their ancestors. Even if no dinosaur lineage ever crossed the threshold into civilization, the fact that some got close in terms of brain power and social structure reminds us that intelligence doesn't belong to mammals alone. It could have risen, peaked, and then been cut short. The end of the non-avian dinosaurs came with a bang. A massive asteroid impact combined with intense volcanic activity and climate chaos. Whatever was happening in those ecosystems, whatever paths evolution was exploring, were abruptly reset. If there had been a dinosaur civilization, it might have died in that cataclysm, its traces destroyed along with 3/4 of all species on Earth. But dinosaurs aren't the only candidates people have wondered about. If the land is unstable and forgetful, constantly being carved and folded and scraped, there's another part of the planet that feels, at first glance, like it might have kept secrets better. The oceans. They cover most of the Earth's surface. They hide mountain ranges taller than Everest and trenches deeper than any canyon on land. And they've been home to complex life for far longer than land has. Life began in the oceans and thrived there for hundreds of millions of years before forests appeared. Even after land ecosystems exploded in diversity, the seas continue to host their own experiments. And some of those experiments look, to us, suspiciously like the early stages of advanced intelligence. Today we see dolphins and whales with complex social structures, tool use in some cases, and communication that might be more layered than we realize. Octopuses that can solve puzzles, recognize individual humans, and escape from supposedly secure enclosures. Fish that use rocks as tools or create intricate sand sculptures as part of courtship. If multiple lineages in the ocean have developed impressive intelligence just in the relatively short time humans have existed, what might have happened if one of them had tens of millions more years to evolve without us around? The oceans, in some ways, are more stable than land. There are no glaciers scraping the seafloor clean. No massive dust storms grinding everything down. Temperatures shift more slowly in the deep. Life can retreat to refuges when surface conditions go bad. For an intelligent marine species, the sea could provide a long, continuous canvas for culture and technology, if those things can adapt to being underwater. Our concept of technology is very land-based. We think of fire, smelting metal, using wheels, constructing with brick and stone. All of that is extremely awkward, if not impossible, underwater, but technology doesn't have to look like ours. A marine civilization might work with coral, growing and shaping into structures over generations. Use shells, bones, and volcanic rock as tools and building materials. Cultivate seaweed, algae, or other marine plants as food sources. Farm or manage populations of certain fish or invertebrates. Their art, if they had it, might involve patterns of shells, shifting schools of bioluminescent organisms, or sculpted sand and rock formations visible only from certain vantage points. Their communication could be rich in sound, light, or even chemical signals. Low-frequency calls that travel across entire ocean basins. Flashes and patterns of bioluminescence. Complex scent trails we wouldn't even perceive. None of that would require writing on stone, and almost none of it would leave durable remains after millions of years. The seafloor itself poses a problem. 2. Remember, oceanic crust is young. It keeps being created and destroyed. The oldest surviving seafloor is only about 200 million years old, and much of it is younger. Anything built on deep ocean crust more ancient than that has already been subducted and melted. Still, not all ocean environments are equal. Shallow seas near continents, reef systems, and coastal shelves can sometimes be preserved as rock when sea levels change and land uplifts. That's why we find marine fossils high up in mountains and deserts today. If a marine civilization built structures or changed environments in those shallower zones, some echoes might remain in rock layers on now dry land. Chemical anomalies could also tell part of the story. Large-scale manipulation of the marine environment, whether for food, energy, or construction, could leave traces in sediment. Changes in nutrient levels captured in the chemistry of ancient mud. Unusual distributions of certain elements from mining or metal use. Organic residues from large-scale farming or waste. But again, nature produces plenty of strange signals all by itself. And there's another twist. Even if fossils of such a species existed, we might not recognize what they were. Without a living example to compare them to, their bones or shells might simply be cataloged as odd extinct marine animal. There'd be no label that says intelligent, tool-using, culture-building species printed on the fossil tag. That's the recurring theme here. Whether we're talking about dinosaurs on land, hypothetical marine civilizations, or something else entirely, the further back we go and the stranger the body plan, the easier it is to miss the clues. The more you think about it, the more you realize that if there were builders before us on land, in the sea, or both, they might not look like we expect at all. They might not be the giants. They might not be the most obvious creatures in their ecosystems. They might even have been small, quiet, and easy to overlook, which brings us to another possibility. That if there were earlier civilizations on Earth, they weren't made by the headline-grabbing giants of prehistory, but by the forgotten builders hiding in the background. When we think about prehistory, our attention usually goes straight to the celebrities. Dinosaurs, mammoths, saber-toothed cats, the creatures with the dramatic bones and the big museum displays. But Earth's story was never written only by giants. Most of the work of life, the quiet, constant shaping of ecosystems, was done by smaller, less flashy creatures. The ones that slip between the legs of the monsters. The ones that rarely make it into movies or onto t-shirts. If there were civilizations before ours, it's entirely possible they didn't belong to the biggest or the most impressive animals, but to those we might call the forgotten builders. Not rulers of entire continents, maybe not top of the food chain predators, but species that lived in stable, sheltered environments. Species that had enough safety and resources to experiment, to learn, to pass things down. Intelligence doesn't always evolve in the spotlight. Sometimes it grows in the margins, in places where survival isn't a constant emergency, and where there's time for curiosity. If we look at the world as it is now, we can already see hints of what those forgotten builders might have been like. Beavers, for example, radically reshape their surroundings. They dam rivers, flood valleys, and create ponds that become new habitats for countless other species. Their constructions can outlast multiple generations. Certain birds weave complex nests from many different materials, each species with its own style. Some even show regional design trends, like different styles of the same craft. Some primates have intricate social lives and pass down techniques for using tools, cracking nuts with stones, fishing for insects with sticks, washing food in water. Ants and termites construct underground cities and towering mounds with ventilation systems, nurseries, and specialized chambers. Their colonies act almost like single superorganisms. None of these quite cross into what we comfortably call civilization by human standards. But they show how behavior, engineering, and social organization can come together in surprisingly sophisticated ways. Now imagine a species that combines several of these traits. The environmental engineering of beavers, the tool use of primates or birds, the social complexity of elephants or dolphins, the long-term tradition of passing down skills from generation to generation. You don't need a creature the size of a dinosaur for that. You just need the right conditions and a lot of time. Physically, such forgotten builders could look like almost anything. Maybe they were small mammals with nimble paws and good depth perception. Maybe they were large birds with strong beaks and grasping feet. Maybe they were reptiles or amphibians that lived in wetlands and forests, with dexterous limbs suited to digging, weaving, or stacking materials. They might have been nocturnal, living much of their lives in dim light. They might have lived underground, in networks of tunnels and chambers. They might have preferred dense forests, where their works were hidden by leaves and shadows. What they built might not resemble our cities at all. Think less stone skyscraper, more woven domes made from branches and vines, elevated walkways linking trees, rebuilt and expanded over generations, terrace burrow systems reinforced with clay, shelters grown from living plants carefully guided into shape. These structures could have been remarkably complex and well-suited to their needs, and yet almost completely invisible to us now. Wood, leaves, fibers, and packed earth vanish quickly once they're abandoned. Within a few centuries, a forest or wetland can reclaim almost anything organic. Within a few thousand years, even the outlines in the soil can be blurred by floods, landslides, and the slow churn of roots and worms. Over millions of years, the odds that those structures would survive in any recognizable form drop close to zero. Even if some of their constructions did leave subtle traces, hard-packed soil layers, unusual root patterns, or faint remnants of hearths or pits, those signs would be incredibly easy to miss or misinterpret. And that's just the buildings. What about the other signs of a civilization? If they altered water flow, damming streams, digging channels, redirecting floodplains, those changes could show up as unusual sediment patterns. But rivers naturally change course. Floods happen even without builders. Distinguishing engineered from accidental would be difficult. If they cultivated certain plants, we might expect to see changes in the fossil pollen record, a sudden increase in one type of plant far from its usual range. But climate shifts, fires, and other natural events can shift vegetation, too. If they hunted in particular ways, we might find animal bones clustered or sorted strangely. But predators, scavengers, and even natural traps like mud pits can create piles of bones that look patterned even when they aren't. From our vantage point, most of the potential traces of a small, subtle civilization blend into background noise of geology and ecology. There's also an interpretive problem. We tend to judge intelligence based on how much a species resembles us. We look for things we recognize: art, writing, elaborate tools, monumental architecture. We value language that sounds like speech, symbols that look like letters, and objects that are clearly decorative rather than purely functional. But another species might have expressed its intelligence in very different ways, through patterns of scent instead of sight, through changes in landscape that feel like good gardening rather than construction, through performances and rituals that left little physical residue. They might have had highly complex oral traditions, mapping vast territories in memory. They might have used constellations, seasonal patterns, and landmarks as a living library. If their culture was mostly spoken, sung, danced, or scented, without durable physical records, then almost everything about their civilization would vanish with them. Even the bodies of these builders might not tell us much. A fossil skeleton can hint at brain size, senses, and movement. It might reveal specialized hearing, keen vision, or strong forelimbs. But it can't directly tell us how they taught their young, whether they told stories, whether they had rituals or symbols, whether they cooperated on long-term projects. We might dig up the bones of a species that once debated, planned, and remembered, and never know how much is going on behind those eye sockets. Evolution also isn't a straight, ever-upward climb. It's full of detours and reversals. Sometimes intelligence increases in a lineage. Sometimes it plateaus. Sometimes it declines if it stops being useful. A species might have evolved impressive problem-solving abilities, used them for a while, then lost them as its environment changed. Another might have reached a kind of proto-civilization, a rich, cultural, tool-using way of life, and then been outcompete or wiped out before those traits became deeply entrenched. In that case, the forgotten builders might have been exactly that, forgotten not only by the planet, but by the evolutionary tree itself. Their line might have ended, leaving no close descendants to carry their legacy forward. Or their descendants might now be ordinary animals we don't think twice about, sharing a distant echo of their ancestors' abilities, but no longer living the way they once did. When we imagine them, It's tempting to turn them into warnings or parables, civilizations that rose and fell before us, leaving nothing but lessons we'll never fully hear. But they don't have to play that role. It's enough to consider that intelligence and culture might have bloomed in forms we would struggle to recognize, and then slipped away without leaving clear marks. Thinking about these forgotten builders changes how we approach the search for ancient civilizations. It nudges us away from only looking for grand ruins and metal tools, and toward more subtle signatures, odd patterns in soil chemistry, sudden, local changes in plant distribution, repeated structures and landscapes that don't match known natural processes. It asks us to leave room for the possibility that deliberate design can be small, soft, and fragile. And it reminds us that a civilization can exist without stone towers and bronze statues. It can also vanish without leaving the kind of monuments we're used to, which leads us straight into the next layer of the puzzle. Not the bones, not the buildings, but the sediments. Because if you really want to know what happened on a planet over millions of years, you don't just look for big, obvious artifacts. You start reading the dirt. When we think about what the past leaves behind, our minds usually jump straight to the obvious stuff. Bones in glass cases, stone tools on velvet pads, pottery shards with patterns still visible after thousands of years. But the truth is, most of the history of life isn't preserved in big, dramatic objects like those. Most of it is written in powder and mud, in layers so thin and ordinary looking that you could walk over them without noticing. It's written in sediment. Sediment is everywhere. It forms at the bottom of rivers and lakes, on the seafloor, in deserts at the foot of mountains. It's made from crushed rock, wind-blown dust, pollen, ash, the remains of plants and animals, all the tiny leftovers of everyday life and geology. Layer by layer, it builds up. Each layer is a snapshot of what was happening at the time it formed. What plants were growing, what the climate felt like, what kind of particles were floating in the air or washing down from the land. If conditions are right, those layers get buried and compressed. Over millions of years, they can harden into rock, trapping all those tiny clues inside. To a trained eye, that rock becomes a kind of timeline. A coarse, gravelly layer might tell you that a fast river once roared through here. Fine, smooth silt suggests a calm lake or quiet part of the ocean. Repeating bands of light and dark can mark seasonal changes, almost like tree rings laid down sideways. Even if there isn't a single obvious fossil, sediment can tell you. Was the climate warm or cold? Was it wet or dry? Was life flourishing or struggling? And if you zoom in further, things get even more interesting. Inside those layers, you can find grains of pollen from ancient forests, tiny shells from plankton that lived in long-dead oceans, spores, charcoal, and microscopic fragments of whatever was happening on the surface at the time. Those microscopic remains are surprisingly tough. A layer suddenly rich in pollen from one plant might mean that species suddenly spread. A layer where that pollen disappears might hint at drought, cooling, or competition. Now, if you're looking for signs that a civilization once walked the earth, this is where the trail might start. Because civilizations, ours included, change sediment. We cut down forests. We farm the same plants over and over. We dig into the ground for metals and fuel. We burn things, build things, dump things. All of that leaves chemical and physical fingerprints in the layers we're laying down right now. You can already see our impact if you look at recent sediments. In places near industrial centers, there are layers enriched in heavy metals like lead, copper, and mercury, byproduct of smelting and fuel use. Coal burning leaves behind distinctive ash particles. Plastics are breaking down into tiny pieces that are raining onto seafloors and lake beds, becoming part of the geological record. Even in places far from obvious human activity, remote lakes, polar ice, deep ocean mud, you can find traces of what we've done carried there by wind and water. Those layers will still be there long after our buildings are gone. If someone millions of years from now drilled a core through those sediments, they'd see something strange, a very thin band full of odd chemistry and unfamiliar materials. From their perspective, it might look like a brief, abrupt event, a weird moment when the planet's usual rhythm slipped and something unusual happened. So if we can leave that kind of mark in just a few hundred years, what would we expect from a civilization that might have existed tens of millions of years ago? we wouldn't be looking for bones arranged in neat city shapes. We'd be looking for anomalies, places where the sediment tells a story that doesn't easily fit with known natural causes. Maybe an unexpected spike in certain metals that don't usually occur together. A sudden shift in the balance of carbon isotopes in a layer, hinting at large-scale burning of carbon-rich material. A patch of sediment rich in compounds that look suspiciously like processed chemicals rather than natural minerals. The problem is, nature is very good at making weird layers on its own. Volcanoes can spread ash and heavy metals across entire continents. Wildfires can blanket regions in soot and charcoal. Climate shifts can cause some plants to dominate for a while, then vanish. Meteor impacts can sprinkle rare elements in a thin, global dusting. A dark band rich in carbon might come from a massive wildfire or from deliberate land clearing. An unusual metal pattern might come from a volcanic eruption or from mining and smelting. A drastic change in pollen could reflect climate change or agriculture. Each of those possibilities has to be weighed carefully. That's why scientists don't usually jump to the most exotic answer. If a volcanic eruption can explain a strange layer, that's the safest bet. If a known climate event fits the timing of a shift in pollen, that's where the analysis usually stops. But if you wanted to seriously consider the possibility of a long-vanished civilization, you wouldn't look for just one strange signal. You look for patterns that overlap. For example, imagine a sediment core that shows a sudden, sharp rise in certain metals, a matching shift in carbon isotopes that suggests lots of carbon was burned, a noticeable change in pollen, showing one plant species suddenly becoming dominant, and signs of rapid warming that don't match known volcanic events. None of those alone would prove anything, but together they might at least justify the question, is this just nature or is something else going on here? Of course, the deeper into the past you go, the more the details smear. Layers get compressed. Chemistry shifts slightly over time. Sediment can be mixed, folded, or partially erased. A single layer might actually represent hundreds or thousands of years blurred into one band. That makes it harder to tell whether multiple signals happened at the same time or just ended up in the same neighborhood in the rock. And even if you do find something interesting, you still have to recognize it as potentially artificial. Right now, we're very good at looking for natural explanations. Continent movements, orbital cycles, volcanic eras, asteroid impacts. We build whole fields of science around understanding those. We have far less practice asking, could this particular weirdness be the echo of something intelligent? That question feels risky. It's easy to overreach, easy to start seeing intentional patterns where there are none. So most of the time, scientists stay cautious. They label unexplained anomalies as unresolved or not yet fully understood and move on. But underneath that caution is a quiet possibility. It could be that some of those anomalies are the ghosts of something more. And if that's true, they might already be sitting in storage reels of data and sample archives, waiting for someone to look at them with a slightly different question in
Even after
mind.
land
Sediments tell
ecosystems
us what the surface of the Earth
exploded
was
in
doing.
diversity,
Chemistry
the
tells us how
seas
the planet was
continued
breathing.
to host
Put
their
them
own
together, and you
evolutionary
get a rough outline of the
experiments.
planet's mood at different points in time. But if you want to push the question even further, beyond rocks and mud and pollen, you eventually end up looking at something even more subtle, the chemical fingerprints of a world that may have once been industrial. Because everything we do, from burning fuel to refining metals to splitting atoms, leaves a mark in the planet's chemistry. And chemistry can last a very, very long time. Think about it. Every single thing we do leaves a chemical trail. Every fire we light releases particular gases and particles. Every factory shifts the balance of elements in the air, water, or soil. Every mine we dig pulls certain metals out of ground and piles them up somewhere else. Those traces don't just vanish. They move, they settle, and some of them get locked away in rocks and ice where they can stay for millions of years. Even when nature does something dramatic, volcanoes, floods, asteroid impacts, it leaves its own chemical calling card. Different events make different patterns. So if you wanted to search the deep past for something like an industrial civilization, chemistry is one of the best places to look. We already know what ours looks like. Since the start of the industrial age, we've raise levels of carbon dioxide, and change the ratio of its isotopes in the atmosphere and oceans, spread heavy metals like lead, copper, and zinc into soils and sediments, release synthetic chemicals that didn't exist before we made them, sprinkled radioactive isotopes from nuclear testing across the planet. Those things don't all last forever, but some of them last a very long time. Carbon isotopes, for example, are a powerful clue. Carbon comes in different flavors, or isotopes, light and heavy. Plants, animals, and fossil fuels each have characteristic ratios of those flavors. When we burn a lot of fossil fuel, we change that ratio in the atmosphere, and that shift gets recorded in tree rings, in shells of marine organisms, in ice cores, and eventually in rock layers made from those materials. Millions of years from now, that isotopic wiggle will still be visible to anyone who knows how to look. If a civilization long before us burned large amounts of carbon-rich material, something like coal, oil, or even a different kind of organic fuel, it could leave a similar wiggle behind. The trick would be separating that from natural processes, like huge volcanic events that also alter carbon isotopes. Mining and metalwork leave their own fingerprints. When you extract metals from ore, you often concentrate certain elements in waste piles. Over time, those piles can leach into nearby sediments, making local spikes in specific metals that don't match the surrounding geology. Imagine finding a layer of rock from 70 million years ago with unusually high levels of copper and tin in an area where the underlying rocks don't normally contain those metals. That might make you pause. But again, nature does strange things too. Mineral-rich fluids can move through rock and concentrate metals in odd places. Hydrothermal vents, for example, build chimneys rich in metals without any help from intelligence. So you want to see more than one line of evidence before you started whispering ancient industry. Then there are synthetic materials. We've created plastics, synthetic rubbers, and all sorts of polymers that simply did not exist in nature before we cooked them up. Many of them resist decay, at least on human timescales, and when they do break down, they tend to fragment rather than vanish. Over millions of years, they'll probably change, oxidize, break into smaller bits, react with other chemicals. But the basic structure of some of these complex molecules could still leave recognizable traces in certain conditions. If a previous civilization had its own version of synthetics, compounds that don't form naturally, those would be very strong signals. If they survived, they might show up as strange carbon-rich particles embedded in sediments, unusual polymer-like structures within certain mineral grains, or chemical residues that don't match any known natural pathway. Right now, when scientists find odd compounds in very old rocks, the first instinct is to look for natural explanations: biological processes, hydrothermal systems, volcanic emissions. Ancient plastic is not high on the standard list of suspects. But as our ability to analyze materials grows, down to parts per trillion in some cases, we're starting to see just how much detail is stored in even tiny samples. That opens the door to noticing patterns that would have been invisible a generation ago. There's also the idea of layered signals. One weird chemical spike might be written off as a fluke. But what if you found a carbon isotope shift, plus an unusual metal pattern, plus a handful of synthetic-like compounds, all in the same narrow slice of time? At some point, the pile of coincidences might start to look more like a story. Of course, the opposite is also true. The absence of these kind of signals would tell us something too. If we looked carefully across many time periods and never found any sign of unnatural chemical combinations, no odd isotopes without a volcanic explanation, no weird metals in stable regions, no synthetic-like residues, then we'd be justified in saying, if there was a civilization before us, it probably didn't have industry anything like ours. Maybe it was small-scale, low-impact, and careful with its environment. Maybe its technologies didn't rely on burning fossil fuels or smelting metals. Maybe it never reached a point where it altered the planet globally. In that case, its chemical footprint could be so faint that it blends into natural background variation. And that's where a famous idea comes in, a thought experiment that tries to turn all of this into a more formal question. If there had been an industrial civilization on Earth millions of years before humans, would we be able to detect it today? This is what's sometimes called the Silurian hypothesis. The name is a little bit of a joke. It comes from an old science fiction story about intelligent reptilian beings, the Silurians, who lived on Earth long before humans, then went into hiding. The scientists who coined the term weren't saying, yes, there definitely were ancient lizard people with spaceships. They were doing something more modest and more interesting, using that sci-fi idea as a springboard for a serious question about evidence. The key authors behind the Silurian hypothesis, Gavin Schmidt and Adam Frank, come from climate science and astrophysics. Their original interest wasn't just Earth's past, but also how you might spot the fingerprints of civilizations on other planets. If we were looking at Mars or an exoplanet through a telescope, what would count as evidence that something industrial once existed there? They started by looking at us. We've already changed the composition of the atmosphere, shifted global temperature trends within a short geological window, spread synthetic chemicals and plastics, and left a thin film of radioactive isotopes and sediments. All of that will show up in the geological record as a distinct marker, a boundary that future geologists could see as clearly as we see the layer from the dinosaur-killing asteroid. That boundary, what some people propose to call the Anthropocene, might last in the rock record for tens of millions of years. Schmidt and Frank asked, if another civilization did something broadly similar long ago, what should we be able to detect now? Their conclusion wasn't, yes, it definitely happened. It was more like, here are the kind of signals industry tends to leave. Isotope changes, strange chemical mixtures, rapid climate shifts. Here's how long those signals are likely to last. And here's how easily they might be erased or masked by natural events. They pointed out something sobering, too. If our civilization collapsed tomorrow and you fast forward the planet a few million years, almost all of our obvious structures would be gone. No skyscrapers, no cars, no bridges. Even our landfills would mostly have been broken down, buried, or transformed. What would remain? A few stubborn artifacts in very specific places. And more reliably, the chemical and isotopic fingerprints in rock layers and sediments. In other words, if someone in the far future wanted to know whether an industrial civilization ever existed around our time, they'd be looking for exactly the kinds of clues we've been talking about. Apply that logic backwards, and you get a roadmap for what to look for in ancient rocks. 2. The Silurian hypothesis doesn't claim there was a civilization before us. It just shows what we need to see for that idea to become plausible, what the limits of our detection are, and how easily time could hide or blur the signals we'd hope to find. It also quietly reminds us of something else. We are not guaranteed to be the only technological experiment this planet ever hosts. We're just the one happening now. And that opens up a deeper, stranger question. Even if another civilization did exist long ago, even if they had tools, cities, industry, and complex societies, there's another layer of their world we might never be able to reach. Their inner life, their language, their stories, their art, if they try to talk to one another, to their future, or even to whoever might come after them. Will we have any hope at all of understanding what they were trying to say? When we talk about a lost civilization, it's easy to picture something we already understand. Maybe we imagine carved symbols on stone, like ancient runes. Or we hear voices speaking in a language we don't know, but can at least recognize as words. We imagine gestures, counting systems, songs. But that's because we're using ourselves as the model. Language, at its core, is just a structured way of moving information from one mind to another. It doesn't have to sound like speech. It doesn't have to look like writing. It doesn't even have to use sight or sound at all. If there was a civilization before us, their way of communicating might have been so different that, even if we found traces of it, we wouldn't recognize it as language in the first place. Human language is shaped by our bodies. We push air from our lungs past vocal cords. We shape that air with tongues, lips, and teeth. Our ears are tuned to a certain range of frequencies, so that's where our speech lives. Our writing uses shapes our eyes can see easily. It fits on surfaces we can hold, carve, or print on. Our gestures work with arms, hands, and facial expressions that other humans can read. But imagine a species whose biology is completely different. Maybe their hearing is tuned to frequencies too high or too low for us. If they use ultrasonic chirps or infrasound rumbles to talk, we might never notice their conversations without special equipment. Maybe their vision stretches into ultraviolet or infrared. Their writing might be patterns that only show up under particular wavelengths of light, invisible to our naked eyes. Maybe their primary language wasn't visual or auditory at all. We already see hints of that on Earth. Dolphins use complex patterns of clicks and whistles that travel far underwater. Cuttlefish and octopuses change the color and texture of their skin in incredible detail, sending signals through flashes and patterns. Bees dance to tell others where to find food. Ants lay down chemical trails that carry information and scent. Now imagine a species that takes one of those systems and turns it up to 11. A civilization of cephalopod-like beings might have used patterns of color and texture as a living, shifting language, written across their bodies in real time. To them, a conversation might look like a flickering tapestry of light and motion. On land, a species might have used scent the way we use text, blended chemical signals with nuanced combinations, leaving trails that acted like written sentences, slowly fading over hours or days. If we stumbled across the remnants of that kind of communication millions of years later, what would we see? Maybe mineral stains in rock where pigments once stood. Maybe ancient glands or skin structures in fossils that hint at complex displays. Maybe nothing at all. We might never know those creatures had a language, let alone what they were saying. Even if there were physical records, some kind of inscription, we'd run into another problem. Translation. When we decipher human scripts, we lean on similarities. We look for something like a Rosetta Stone, the same text written in multiple languages, at least one of which we understand. We search for repeated patterns that might be numbers, names, or common words. But for a non-human language, we wouldn't even know what concepts they cared about. Their words might be built around senses we don't have. They might mark time differently. They might not separate ideas into nouns and verbs the way we do. A carved spiral might have been a map, a poem, a law, or all three at once. Without a living culture to show us how it was used, we just see the spiral, and that's assuming they recorded anything at all in durable form. Humans write things down because we know our memories are limited, and we want certain information to outlast us. But another species might have leaned into impermanence. Their stories could live only in performance, in songs, dances, scent displays, color shows, meant to exist in a moment and then disappear. Their knowledge might have been passed entirely from mind to mind, held in the living network of their society and never preserved in stone. If so, almost everything about their inner lives, their jokes, their myths, their fears, their hopes, would vanish the moment they did. Even then, if they were advanced enough, it's hard not to imagine that they would have created something we'd recognize as art. Art is one of the clearest signs that a mind isn't just surviving, it's reflecting. It's taking something inward and turning it into something outward. We like to think of art as uniquely human, but we already see shadows of it elsewhere. Bowerbird built elaborate structures decorated with colored objects, arranged in patterns that seem to show preference and creativity. Whales sing long, evolving songs that appear to change over time, almost like shifting musical traditions. Some primates make marks or stack objects in ways that don't have an obvious practical purpose. So, if a pre-human civilization existed, it's not a stretch to imagine that they had their own forms of art. Maybe they carved intricate patterns into soft materials that didn't last. Maybe they shaped sound in frequencies we can't hear, or light in ranges we can't see. Maybe they grew living sculptures, trees, corals, or fungi guided into deliberate shapes over decades. The problem, again, is survival. Paint fades. Wood rots. Fabric disintegrates. Even stone wears away under wind and water. Most human art wouldn't last 1,000,000 years, let alone 50. What to survive from our deep past, cave paintings, stone carvings, simple figurines, was protected by unusual conditions. Dry caves, buried ruins, low disturbance. If another civilization's art lived mostly in damp forests, shallow seas, or on soft ground, the odds of any of it surviving to reach us now are tiny. And even if a tiny bit did remain, a carved stone hidden in some sheltered pocket of rock, would we recognize it? a pattern that meant everything to them might look abstract or random to us. Their favorite symbols might resemble natural cracks or crystals. Their finest sculptures might have been smoothed down to anonymous lumps. We could be walking past their masterpieces without knowing it. Art and language are deeply wrapped up with something else too. Identity, the way a civilization expresses itself, through stories, songs, images, rituals, is a reflection of how it sees the world and its place in it. If such a civilization once existed here, their art might have told the story of their rise. It might also have told the story of their fall. Because just like ours, any civilization they built wouldn't have been static. It would have had a beginning, a time when scattered groups started sharing more, building more, coordinating more. Maybe they started with simple shelters and basic tools. Over time, those might have become more refined, specialized, and varied. They might have developed roles within their communities: builders, navigators, healers, storytellers. As they spread, they might have adapted to new environments: forests, coasts, mountains, or seas. Different groups might have taken different paths, creating a patchwork of cultures linked by trade or shared ancestry. At some point, they would have had to grapple with complexity. Who gets what resources? How do we settle disputes? How do we manage growth? For us, that led to systems, governments, laws, customs, agreements. For them, it could have been something very different: ritual structures, chemical contracts, shared memory practices. But complexity always has a cost. The more tightly a civilization is woven together, the more stress it feels when conditions change. A shift in climate that once would have just moved a few herds or changed plant patterns might have suddenly threatened food supplies for millions. An environmental decision, overharvesting, habitat destruction, pollution, might have seemed fine at first, then cascaded into a crisis. Or the danger could have come from outside: an asteroid, a burst of volcanic activity, a slow but relentless change in the planet's orbit or tilt. Whatever they were, these pressures would have tested their ability to adapt. Did they slow down and change course? Did they double down and push harder? Did they fragment into competing groups with different responses? We don't know. We can't know. But what we do know from our own history is that civilizations are delicate. They can be undone by the very systems that make them powerful. Their dependence on specific resources, their tight interconnections, their assumptions about what will always be there. If a pre-human civilization ever reached that point, spread wide, entangled with its environment, confident in its own permanence, then it stood on the same kind of edge we do now. And just like us, it would have had a choice: adapt or risk collapse. If they failed to adapt, their decline might have been slow, a long, ragged
Most of
unraveling,
it
or
is
brutally
written
fast,
in powder
driven by
and
sudden
mud in
catastrophe.
layers,
Either
so
way,
thin and
from the planet's
ordinary
point of view,
looking
the
that you
result would have
could
been the
walk
same in the
right
long
over
run.
them
Their
without even
cities,
noticing.
however they looked, would crumble. Their languages would go silent. Their art would fade. Their species might shrink, scatter, or vanish altogether. Time and geology would get to work. And millions of years later, another species, ours, would stand here, looking back in the fog they left behind, and wonder, were we really the first ones to ask these questions? Or are we just the first ones left? There's a funny thing that happens when you spend a long time thinking about civilizations that might never have existed. At
Each
first,
layer is a
it feels like a
snapshot
kind of
of what
escape.
was
You
happening at
drift
the
into
time
pictures of
it
ancient
formed.
oceans with unknown
What
cities
plants
beneath
were
them,
growing,
forests
what the
full of careful
climate
builders
felt
we'll never
like,
meet,
what kind of
dinosaur minds
particles
wondering
were
about their own
floating in the
futures.
air
But
or
after a
washing
while,
down from the
the direction of the
land.
gaze flips. You're not really looking at them anymore. You're looking at us. Because whether or not there was ever another civilization before ours, we now know enough about the planet and about ourselves to see the shape of the challenge we're in. We're an intelligent species standing in the middle of a world that's been changing for billions of years, and we've just recently learned how to change it on purpose. We've altered the atmosphere. We've reshaped landscapes. We've moved species, dammed rivers, lit up the night sky. In geological terms, we've slammed our signature into the rock record in an instant. The question hiding underneath all this talk of ancient, hypothetical civilizations is really this: what kind of mark do we want to leave? Imagine someone or something studying the Earth 50 million years from now. They don't see our buildings. Those are long gone. They don't see our languages or our art. Those vanish with us. What they see instead are layers. A thin band of rock with a sharp spike in carbon isotopes. Traces of synthetic compounds that don't fit any natural pattern. Unusual distributions of metals and microscopic particles that appear suddenly and then fade. From that distance, our entire era might look like a brief, bright flare, a sudden deviation in the planet's long, steady rhythms. They might give it a name. They might argue about what caused it. They might ask whether whatever did to survive the consequences, or didn't. In a way, we're already writing that chapter of the Earth's autobiography. Every decision we make about how we use energy, how we treat ecosystems, how quickly we consume resources, it all feeds into the story the planet will record about us. Thinking about possible civilizations in the deep past doesn't give us definite answers about our own future, but it does give us perspective. If intelligence can emerge more than once, it's not the rare, fragile miracle we sometimes imagine. It's a possibility written into the nature of life itself when the right conditions come together. If civilizations can rise, flourish, and then vanish so completely that only chemical whispers remain, then we're not automatically different just because we have smartphones and telescopes. We might be unusual. We might be early. We might be late. Or we might just be the current chapter in a very long book. That thought can feel unsettling. It makes our achievements look less permanent. It reminds us that being clever is no guarantee of being careful. But there's another way to feel about it. You can also see it as an invitation. If we are part of a pattern, a recurring cycle of intelligence on this planet, then we have a chance to try something new with it, to see our own impact clearly while it's happening, to understand the forces that might undo us before they do, to treat our time here as something we're responsible for, not just something we're entitled to. If we're the first and only civilization the Earth will ever host, that responsibility is even heavier. There may never be another species with this kind of reach, this kind of awareness. In both versions of the story, the choice sitting in front of us is the same. Do we live as though the world is here purely to be used up, or as though it's something we're borrowing for a while? The deep past won't answer that for us. The sediments and fossils and chemical traces can show us what has happened, but not what must happen next. That part is on us. It's worth pausing, too, on the strange comfort of mystery. We don't know if there was a civilization before ours. We may never know. The evidence, if it exists at all, might be too faint, too scattered, or too altered to ever form a clear picture. But the question itself has value. It keeps us curious. It keeps us humble. It stretches our imagination beyond the walls of our own time. When we picture minds in the deep past, dreaming under alien constellations, building in forests that no longer exist, singing in oceans arranged very differently from today, we're not just inventing stories. We're practicing something important. Learning to see ourselves as part of a much larger, older process. A planet that has hosted countless forms of life. A biosphere that has stumbled, recovered, and reinvented itself after disaster. A story that did not start with us and will not end with us, even if we imagine we're the main characters. From that viewpoint, our technology stopped looking like the final word and start looking like early drafts. Our mistakes become part of the learning curve, not the whole story. Our successes, when we do protect something, restore something, understand something deeply, become part of the legacy we pass on, whether to future humans or to whatever comes after. There's also something quietly beautiful in knowing that not every question has to be solved. Some can remain open, like windows. The idea of a pre-human civilization is one of those. We can probe it with data, sharpen it with hypotheses, test pieces of it. But some part of it will probably always sit in that thin place between what we know and what we can only imagine. And that's okay, because that thin place, the edge between knowledge and wonder, is where a lot of our best thinking happens. It's where scientists decide to drill one more core sample because a pattern looks just a bit too odd. It's where someone in a quiet lab looks an unexplained anomaly and thinks, we've missed something. It's where a curious mind sitting in the dark, listening to a podcast or watching a video, feels the horizon of their world stretch just a little further. That's you right now. You, and I can't go back and walk those ancient landscapes. We can't sit beside an ocean 200 million years ago and watch to see if anything looks suspiciously organized on the seafloor. We can't stand in the shadow of a dinosaur herd and tell whether one of them is wondering about the stars. But we can do something that's almost as powerful. We can let the possibility that others might have existed change how we see ourselves. We can remember that if intelligence is not unique, then humility makes sense. We're not the crown of creation. We're a recent development on a very old stage. We can remember that if civilizations can vanish without a trace, then permanence is an illusion. The things we build matter, but they're not guaranteed to last. What echoes longest may be how we change the planet, for better or worse. And we can remember that if the Earth has hosted many experiments in life, then ours doesn't have to be the last or the most short-sighted. Somewhere in the rock record, there might already be faint lines telling a story we'll never fully read. Maybe they belong to no one but nature itself. Maybe they belong to us alone. Maybe they belong to someone who stood where we stand now, long ago, wondering if they were alone. We may never know. But tonight, in this small shared moment, your screen glowing, my words reaching you across distance, that mystery is part of the company we keep. We're not just talking about dinosaurs or sediments or hypothetical ocean empires. We're talking about what it means to be a thinking creature on a changing world with limited time and an unlimited capacity for questions. And that, I think, is a pretty good thing to fall asleep thinking about. So wherever you are, whether night has wrapped itself around your window or daylight still sitting on the sill, thank you for wandering through deep time with me. If this kind of slow, curious journey feels like the right kind of company for you, I'd be glad if you liked the video, subscribe, or shared it with someone else who might need a gentle, wandering thought to drift off to. It seems small, but it helps keep this little corner of quiet conversation alive, and maybe lets a few more minds step into these long, strange questions with us. For now, let the mystery be what it is. Let the Earth's long memory, with all its gaps and silences, sit beside your own. Rest well, dream freely, and remember, somewhere, written in stone and sky and sea, the story is still going. We're just one chapter. But while we're here, we get to help decide how this part of it reads.